Welcome to the world of programming. In this video, we'll explore the essential concepts that form the foundation of all programming languages. Whether you're interested in building websites, creating apps, or automating tasks, understanding these basics is your first step. Programming is all about giving instructions to computers to solve problems or perform tasks. We'll start with the simplest ideas and gradually build up your knowledge, so don't worry if you're completely new. Let's begin our journey into the fascinating world of code, where logic and creativity come together to make amazing things happen. Program is a set of instructions that a computer follows to perform a specific task. Think of it as a recipe. Just as a recipe tells you step by step how to make a dish, a program tells the computer what to do step by step. Programs can be as simple as adding two numbers or as complex as running an entire website. Every program is written in a programming language, which is a special way of communicating with computers. Understanding what a program is helps you see the bigger picture of how computers work and how you can control them. Programming languages are the tools we use to write programs. There are many different languages, each with its own strengths and uses. Some popular ones include Python, JavaScript, and Java. These languages allow us to communicate instructions to the computer in a way it can understand. Just like learning any new language, it takes practice to become fluent. The good news is that once you understand the basic concepts, you can apply them to almost any programming language. Choosing the right language often depends on what you want to create. Every programming language has its own syntax and semantics. Syntax refers to the rules about how you write code, like where to put parentheses or how to end a statement. Semantics is about what the code actually means or does. Think of syntax as grammar in a spoken language and semantics as the meaning behind the words. If you make a mistake in syntax, the computer won't understand your instructions and will give you an error. Learning the syntax and semantics of a language is essential for writing correct and effective programs. Variables are like containers that store information for your program to use. Imagine a box labeled score, where you keep track of a player's points in a game. In programming, you create variables to hold data such as numbers, text, or other values. You can change what's inside a variable as your program runs. Variables make your code flexible and powerful because you can use them to store and update information as needed. They are one of the most fundamental building blocks in programming. Data types define what kind of information a variable can hold. The most common data types are numbers, text called strings, and true-false values called booleans. For example, you might use a number to store someone's age, a string to store their name, and a boolean to track if they're a member. Understanding data types helps you organize and manage information in your programs. Each programming language has its own way of handling data types, but the basic ideas are similar everywhere. Operators are special symbols or words that let you perform actions on variables and values. The most common operators are arithmetic ones like addition, plus, subtraction, multiplication, and division. There are also comparison operators like equal to, equals, or greater than, which help you compare values. Logical operators such as and or let you combine conditions. Operators are essential for making calculations and decisions in your code, allowing your programs to process and analyze data. Programming, an expression, is a combination of values and operators that produces a result. For example, 2 plus 3 is an expression that evaluates to 5. A statement is a complete instruction that tells the computer to do something, like assigning a value to a variable. Every program is made up of many statements, some of which include expressions. Understanding the difference between expressions and statements helps you write clearer and more effective code. Input and output, often called I/O, are how your program interacts with the outside world. Input is information your program receives, like a user typing their name. Output is information your program sends out, such as displaying a message on the screen. Most programs need some way to get input and provide output, making I/O a fundamental concept. Learning how to handle input and output lets you create interactive programs that respond to users and share results. Control flow is the order in which instructions are executed in a program. By default, code runs from top to bottom, but sometimes you want to make decisions or repeat actions. Control flow structures like if statements and loops let you control which parts of your code run and when. Mastering control flow is key to writing programs that can make choices and handle different situations automatically. Statements are a way for your program to make decisions. They check whether a condition is true or false and then run different code depending on the result. For example, you might use an if statement to check if a user's password is correct before letting them log in. If statements are the building blocks of decision-making in programming, allowing your code to react to different situations. Else and else if statements work with if statements to handle multiple possibilities. If the first condition isn't true, else if lets you check another condition, and else provides a default action if none of the conditions are met. This structure helps your program handle complex decision-making, making it more flexible and responsive to different inputs or situations. Loops let your program repeat actions multiple times without writing the same code over and over. The two most common types are for loops and while loops. For loops are great when you know how many times you want to repeat something, while loops keep going as long as a condition is true. Loops are essential for tasks like processing lists of data or performing calculations repeatedly. For loop is a type of loop that repeats a block of code a specific number of times. For example, you might use a for loop to print numbers from 1 to 10. The for loop is especially useful when you know in advance how many times you want to repeat something. It helps you write concise and efficient code for tasks that involve counting or iterating over a list. A while loop repeats a block of code as long as a certain condition is true. Unlike a for loop, you don't always know how many times it will run. For example, you might use a while loop to keep asking a user for input until they enter the correct answer. While loops are powerful for situations where the number of repetitions depends on changing conditions. Functions are blocks of code that perform a specific task and can be used over and over. Instead of writing the same code multiple times, you can define a function once and call it whenever you need it. Functions help organize your code, make it easier to read, and reduce mistakes. They are a key part of writing efficient and maintainable programs. To create a function, you give it a name and specify what it should do. You can also define what information called parameters the function needs to work. For example, a function called addNumbers might take two numbers as parameters and return their sum. Defining functions lets you break big problems into smaller, manageable pieces. Once you've defined a function, you can use it by calling its name and providing any required information. This is known as calling the function. For example, if you have a function that adds two numbers, you can call it with different numbers each time. Calling functions makes your code more organized and allows you to reuse logic easily. Functions can send information back to the part of the program that called them. This is called returning a value. For example, a function that adds two numbers can return the result so you can use it elsewhere in your program. Return values make functions more useful and flexible, allowing you to build complex programs from simple building blocks. Parameters are the names you use in a function definition to specify what information the function needs. Arguments are the actual values you provide when you call the function. For example, in a function that adds two numbers, the parameters might be number 1 and number 2, and the arguments could be 5 and 7. Understanding the difference helps you use functions correctly. Comments are notes you write in your code to explain what it does. They are ignored by the computer but help people, including your future self, understand your logic. Good comments make your code easier to read, maintain, and debug. It's a good habit to write clear comments, especially when your code gets more complex. Debugging is the process of finding and fixing errors in your code. Everyone makes mistakes, and debugging helps you figure out what went wrong and how to fix it. Common errors include typos, incorrect logic, or using the wrong data type. Learning to debug is an essential skill for every programmer, and it gets easier with practice. There are several types of errors you might encounter while programming. Syntax errors happen when you break the rules of the language, like missing a parenthesis. Runtime errors occur when your code tries to do something impossible, like dividing by 0. Logic errors are mistakes in your program's logic, so it runs but doesn't do what you expect. Recognizing these errors helps you fix them faster. Indentation and formatting make your code easier to read and understand. Many programming languages use indentation to show which lines of code belong together, especially in loops and functions. Consistent formatting helps you and others quickly see the structure of your code, making it easier to spot mistakes and maintain your programs. Lists are a way to store multiple pieces of information in a single variable. For example, you might use a list to keep track of all the scores in a game. Lists make it easy to organize and process groups of related data. You can add, remove, or change items in a list as your program runs. To use the information in a list, you need to access individual items. Most programming languages let you do this by using an index, which is a number that tells you the position of the item in the list. For example, the first item is usually at index 0. Accessing list items lets you work with specific pieces of data easily. You can change the contents of a list by adding, removing, or updating items. Most programming languages provide built-in ways to do this, such as append to add an item or remove to delete one. Modifying lists is useful for keeping your data up to date as your program runs and responds to new information. Dictionaries are another way to store data, using key-value pairs. Instead of just numbers, you can use words or other types as keys to look up values. For example, you might use a dictionary to store a person's name and their phone number. Dictionaries are great for organizing information that you want to access quickly by a specific label. To get information from a dictionary, you use the key associated with the value you want. For example, if you have a dictionary of names and phone numbers, you can look up a phone number by providing the name as the key. This makes dictionaries very efficient for finding specific pieces of information quickly. Just like lists, you can add, remove, or update items in a dictionary. You can add a new key-value pair, change the value for an existing key, or remove a key entirely. Modifying dictionaries lets your program adapt to new information and keep your data organized as things change. Boolean logic is the foundation of decision-making in programming. It deals with true and false values called booleans. You use Boolean logic to create conditions in if statements and loops. For example, you might check if a number is greater than 10 or if two values are equal. Understanding Boolean logic helps you write programs that can make smart decisions. And, or, and not are logical operators that let you combine or modify conditions. And requires both conditions to be true, or requires at least one and not reverses a condition. For example, you might check if a user is both a member and has paid, or if they are a member or an admin. These operators make your programs more flexible and powerful. Comparison operators let you compare values in your code. The most common are equal to equals, not equal to equals, greater than, less than, and their combinations. These operators are used in conditions to help your program make decisions, such as checking if a score is high enough to win a game. You can combine multiple conditions using logical operators to create more complex decision-making in your programs. For example, you might check if a user is over 18 and has agreed to terms before allowing access. Combining conditions lets your code handle a wider range of situations and respond appropriately. Nested structures are when you put one control structure inside another, like an if statement inside a loop. This lets your program handle more complex logic, such as checking multiple conditions for each item in a list. Nesting is a powerful tool, but it's important to keep your code organized so it's easy to read and maintain. Scope refers to where a variable can be used in your program. Some variables are only available inside a function or loop, while others can be used anywhere. Understanding scope helps you avoid errors and keep your code organized. It's a key concept for writing reliable and maintainable programs. Global variables can be used anywhere in your program, while local variables are only available within a specific function or block. Using local variables helps prevent accidental changes to important data, while global variables are useful for information that needs to be shared across your program. Choosing the right type of variable is important for keeping your code safe and organized. Libraries are collections of pre-written code that you can use in your programs. Importing a library lets you access powerful features without having to write everything from scratch. For example, you might use a library for math calculations, working with dates, or creating graphics. Learning to use libraries saves time and lets you build more advanced programs. Many programs need to save information or read data from files. Reading and writing files lets your program store data for later use or process information from outside sources. For example, you might save a user's progress in a game or read a list of names from a file. File operations are a key part of many real-world programs. Error handling is about making your programs robust by dealing with unexpected situations. Instead of crashing, your program can catch errors and respond gracefully, such as showing a helpful message or trying again. Learning to handle errors makes your code more reliable and user-friendly. An algorithm is a step-by-step process for solving a problem. In programming, algorithms are used to plan how your code will accomplish a task, like sorting a list or searching for a value. Learning basic algorithms helps you think logically and write more efficient programs. Testing is the process of checking if your code works as expected. You can write tests to automatically check different parts of your program or test it manually by trying different inputs. Testing helps you find bugs early and ensures your program does what it's supposed to do. Version control is a way to keep track of changes to your code over time. Tools like Git let you save different versions, work with others, and go back if something goes wrong. Version control is essential for teamwork and for keeping your projects organized and safe. Following best practices helps you write clean, efficient, and reliable code. This includes using meaningful variable names, writing clear comments, keeping your code organized, and testing regularly. Good habits make programming easier and help you avoid common mistakes as your projects grow. You've now learned the basic concepts that every programmer needs to know. From variables and data types to loops, functions, and error handling, these building blocks will help you start your programming journey. Remember, the best way to learn is by practicing and experimenting with your own code. With these fundamentals, you're ready to explore more advanced topics and create your own projects. Happy coding!